night from 1 to 2:30 p.m. in the gym.
I want you to make a scatter
college
diagram
fair.
for this data. We need slope, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we get
You are dismissed to the gym if you have dressed for the season.
take a quick. Okay, so we're trying to write the equation of this line. So we found our slope. So now if we pick one of our 2 points, I'll go the first one. Y equals m times x plus b. And if you solve for b, can I kind of skip my work and tell you you get b equals 7.44?
Where did you get 5?
Yeah, it's 5.7.
I don't know.
Oh.
Because
That's why you show your work.
yes, that's why you don't skip steps, guys. Come on. So how about 7.64? So my final equation is y equals negative 0.97x plus 7.64. So let me ask you a question. If you did your scatter plot and you made your line of best fit and picked 2 points on it and wrote the equation, would your equation be the same as mine?
No.
Probably not. That's the downside of doing it this way. So this is how you've done it in the past. You know, algebra 2, you tried to draw your line of best fit, but there's always a little variability there because we're not precise in doing that. We can use it to make predictions. Now, if all of us have a decent equation, then our predictions will be close, but they're not going to be the same. So if x equals 3, so all you have to do is plug in your 3. And so we get 4.73. So once you have an equation, you can make predictions with it. Okay? But we know this is just a prediction. It's probably not the true answer. So in statistics, a lot of times we talk about residuals. So if you guys look under your chapter 4, the second column, the first bullet there is residual. It's your observed y minus your predicted y. So we don't have to write that in our notebook. We've got it on our formula sheet. The residual is just your difference in what actually happened and what you predicted would happen. So we're going to talk about that. If I wanted to, did I have 3 as an actual point here? I did. So if I wanted to find the residual for this, when x equals 3. Residual is your observed, so my observed value when x is 3 was 5.2 minus my predicted. What did I predict?
7.6 or 4.73.
And so if you subtract that, your residual is 0.47. So the true value was 0.47 hundredths above what we predicted. Okay. We're also going to talk about the regression line. So the least squares, we just did a line of best fit here. The best line we can do is what's actually called the least squares regression line. Now, you don't have to write all this down. If you look on your chapter 4, this is the thing right under your correlation coefficient. So it's just your equation of the line. And we use y hat to represent the least squares regression line. So instead of just a plain y, they typically do a y hat. Your slope and y-intercept, it's a little more precise than just looking at our graph and trying to guess where the best thing is. It's actually found by doing r, which we've seen r before. That is the correlation coefficient, times What are those S's? Standard deviation in y divided by the standard deviation in x. That gives you your slope. The y-intercept, what's this y bar and x bar? The means, and that b sub 1 is the slope of our least squares regression line. So your calculator, we're going to use the calculator a lot of times to write this. This is where that line of best fit comes from in your calculator. This is actually what it is doing when it finds that best line. So again, all of that is directly off your formula sheet, so you don't have to memorize any of that. So let's look at this example. So this chart we saw in our notes yesterday. You might, if you have that handout, you might pull it out. I want to find the least squares regression line. So let's pull some of our information from yesterday when we did this example. We found the correlation coefficient yesterday. We had the mean and standard deviation for both x and y. I think we wrote all that down yesterday, so help me out here. What do we get for the r? What was the mean of the x's? Standard deviation of x. Mean of the y. Standard deviation of the y. Okay, so all of that was from yesterday. So if I wanted to write this equation by hand, let's look at our formula sheet. We need our slope and our y-intercept. Okay, the equation is your y hat equals b sub 1 times x plus b sub 0. So on your formula sheet, b sub 1 is r, so that's negative 0.9456, times standard deviation in y divided by the standard deviation in x. Okay, so I'm just plugging these numbers into my formula. And then put in my calculator. So we get the slope to be negative 2.166. The y-intercept, so if you look in your formula sheet, it says your b sub 0 is y bar, so the mean of the y's, minus b sub 1, that's our slope, times x bar, so the mean of the x's. And I get 18.6664. So my actual equation, my least squares regression line, is negative 2.1666x plus 18.6664. So this is the best line. It would minimize all of the residuals, so it'll make the difference between what we predict and what we actually see as small as possible. So again, not every point in your scatter diagram is going to fall on this because we know it's not perfectly linear, but this is the best line we can get. Alright, so it's really just a matter of plugging those numbers into a nasty looking formula. Is everybody okay with how I got that? So just a couple more things. Sometimes you might hear somebody say you're working outside the scope of the model. We make this line, we wrote our equation of this line, but if you're thinking back to this data, my x's here were between 1 and 7. Okay, so this is the best line here. Does that mean if my x was 75 that this line would be the best option? No. A lot of data, it's going to change over time. If we're looking at population models, we can't expect population growth to be the same in 200 years as it is right now. So the line allows you to make some predictions, but within reason. You need to be plugging in x's that are fairly close to the x's that were used to write the equation of the line. If you have something that's really an outlier, your line is probably not going to be a good predictor for that. So that's not necessarily something I'm going to put on test. What does this mean? But just kind of so we're aware, our line only works for similar types of values. Okay, so I would like to do one on the calculator as well. So if I asked you to do it by hand, it would have to be a pretty small data set, or I would have to, maybe like this one, I'd give you all of these values and just see if you can create the equation. But for most of our scenarios, we are going to need something a little more efficient, so we are going to be using our calculator. So what you need to do is go to your stat edit, and I want you to enter this data in your L1 and your L2. Does everybody have all of this in here? First, we should probably make sure that it does appear to be linear data. So let's look at our scatter plot. Remember, if you go to your stat plot, your plot number 1, turn that on to a scatter plot. And then if you go to zoom number 9, that will zoom to those points. So I get a pretty linear looking positive relationship when I'm looking at my scatter plot. Does everybody get that scatter plot? Alright, anybody else having trouble? Oh, sorry, I just pressed the Make sure your plot number 2 is turned off for me. That'll kind of change things if you have stuff entered in there.
Yeah, I already have it this
You had it, so hit zoom 9. Okay. So this does appear to be linear. So to get the least squares regression line, you want to go to stat, over to calculate, and this is the same one we went to yesterday when we got the correlation coefficient. So do you guys remember which one that was? Number 4, the linear regression. Then you should just be able to enter through, and it tells you y equals ax, and the a is 3.1661. So my equation y hat x plus b, which is negative 55.7966. So there is my 1. Oh, that was part A. Sorry, I wrote it on the wrong one. But now we could draw the line on our graph if you wanted to kind of compare. If you go to your y equals, we just need to enter this into y1. And if you look at your graph, it should draw that line going through your scatter plot. And you can tell that it is a pretty good fit for the data. Predictions from it. So I want to predict how far the golf ball will travel when the speed is 103 miles per hour. So this 103, is that the X or the Y? X. So you're just plugging this in. And so we get 173.3117, and our Y was measured in yards. Okay, I'm going to ask you to do a residual. So if you forget what a residual is, you have that formula sheet that tells you. Residual is, remember it's on the, under that chapter 4, it's your observed minus your predicted. So when the speed was 103 miles per hour, what was the actual observed?
234.
Minus our predicted was,
27.3.
okay. And so our residual is 3.688, or about 2.7 yards, or 3.7 yards. So that's how far off we are. I might ask you to interpret slope and y-intercept. So that's just, what does your slope mean? What does your y-intercept mean? Think about slope. It's change in y over change in x. So y was in yards, x was miles per hour. So the slope is telling me the ball will travel make sure you're using the number for your slope as well as units, so it'll travel 3.1661 yards. You could give it as a rate per mile per hour, so basically if you hit it a mile per hour faster, it will go an additional 3.1661 yards. The y-intercept, what is that telling me? Your y-intercept is when x is 0. So that's like your starting position. Or your position at time 0. Questions here? Okay. So this is the assignment. I have not collected the 4.1. I'm just going to collect 4.1 and 4.2 on Monday.